Hello everyone, this is the group 10 and the members of this group are Krupa, Ritesh, Siddhanth, Parth, Ankit, Shruti, Bushra, Eabez, Lakshman and Arathi. The topics that we will be discussing in this section is the C# language, .NET, types, objects and namespaces.
Hello guys, myself Siddhanth, and today in this presentation I will be going to speak about introduction to .NET. So now let's see the topics which will be covered in this presentation. So first we have the .NET framework, then common runtime language, and finally we have the .NET class library. So now let's see each topic in detail. So first we have the .NET framework, which includes all the components which are used in .NET technology. So first we have the .NET languages, which include languages like Visual Basic, C#, F#, and C++. Although third-party developers have created hundreds more. Then we have the common runtime language. So common runtime language is the engine that executes all the .NET programs and provides automatic services for this application, such as security, checking, memory management, and optimization. Then we have the class library for .NET framework. So this class library collects thousands of pre-built functionality that you can snap into your application. Then we have the .NET class library. So the .NET class library is a giant repository of classes that provide prefabricated functionality for everything from reading an XML file to sending an email message. So any .NET language can use the .NET class library feature by interacting with the right objects. This helps encourage consistency among different .NET languages and remove the need to install numerous components on your computer or web server. So you can see here we have the .NET, ADO.NET data access, XML file, web forms, window forms, file input output. So these are all included in the class library of .NET. So you can think of class library as a well-stocked programmer's toolkit. Then we have the common language runtime. So the common language runtime is the engine that supports all .NET languages. All the .NET runs inside the CLR. That is true whether you are running a Windows application or a web service. For example, when a client requests an ASP.NET web page, the ASP.NET service runs inside the CLR environment, executes your code, and creates the final HTML page to the client. So you can see the things included in are compiler and loader for loading the classes, code verification and optimization, memory management and garbage collection, code access security, and other managed code segments. So this was all about the .NET introduction about .NET framework. Thank you.
Hello, my name is Bushra Khan and I'll be covering data types and its conversions. So, what is data type? A data type specifies the type of data that a variable can store, such as integer, float, character, etc. Data type is further divided into value data type, reference data type, and pointer data type. Value data type has short, int, character, float, double, etc. And reference data type has string, class, object, and interface. Pointer data type has pointer. What is value data type? In value data type, variables can be assigned a value directly. The value type directly contain data. Some of the example of value data type are integer, character, float. Reference data type. Reference data types do not contain the actual data stored in a variable, but they contain a reference to the variables. In short, they refer to a memory location, and examples of reference data type are object, dynamic, and string. Pointer type variables store the memory address. Okay. So next is type conversion. What is type conversion? It is nothing but converting one data type to another, and it is known as typecasting. And type conversion has two types: implicit type conversion and explicit type conversion. Implicit type conversion, these conversions are performed by compiler. No special syntax is required. For example, conversion from smaller to larger integer types and conversions from derived classes to base classes. Next is explicit type conversion. These conversions are done explicitly by users using the predefined functions. Explicit conversions require a cast operator. Cast operator is required when information might be lost in the conversion. An example for type conversion is from numeric conversion to a type that has a smaller range. Next is example of implicit type conversion. Here we have written a code and its output before conversion is 50 and after conversion is 50.00. Before conversion is in the integer part and after conversion is float part. And here we have not lost any data. Explicit example, here the output before conversion is 165.15, that is a float point, and after conversion 0.15. Here we have lost 0.15. Thank you.
Hello ma'am, my name is Lakshman Machigar and I will be explaining the topic conditional logic under C# language. Conditional logic will be having two parts, the statements and the loops. Under the statements we will be having the first if-else statement. The if-else statement will have the condition for the if condition. If the data satisfy the condition, the statements will be executed. An example of code is also been seen on the screen. We'll have a look over it where A is less than B and the statement is being printed out. And if A is equal to B, the sentence U1 sentence will be printed. So if the variable satisfies the condition, the output will be printed out. So as seen in the output, the variables have been printed. The next is the nested if statements. Under the nested if, we have multiple nested conditions and the statements will be executed if the data satisfies the condition. Under the if else if statement, we have multiple else if conditions. The same operation will be carried out over here. We have the next we have the switch statements. Under switch statements we have one single expression and multiple cases will be given to check whether the data satisfies which of the conditions. And under the nested switch statements we have multiple switches in which we have multiple cases to see which different cases and sub cases will the data satisfy the condition. The next we have the condition logic operators under C# language, which consists of the five major operators: less than or equal to, greater than or equal to, and not equal to. Next we have the loops, which will be having the for and the for each loop. For the for each loop, we will be having whatever body it will represent the entire elements for it, whatever we have assigned. And for the for each loop, we will be having the operation for each element of the for loop.
Hello, my name is Krupa Shruti and I am going to present the method parameters in C#. Method parameters. First one is the value parameters. A value type variable directly contains data in the memory. Next is passing parameters by value. This is a default mechanism for passing the parameters to a method. In this mechanism, when a method is called, a new storage location is created for each value parameter. The value of the actual parameters are copied into them. The example demonstrate is the n is the value type. N is the value type. It contains its data, the value 5. When squareit is invoked, the contents of the n are copied into the parameter x, which is squared inside the method. In main, the value of the n is the same after calling the squareit method as it was before. The change that takes place inside the method only affects the local variable x. Next is the reference parameters. The variable is passed as a reference type which only contains the reference or the location of the memory is passed. Parameters of reference. The reference parameter represents the same memory location as the actual parameter. You can declare the reference parameter using the ref keyword. The method operates on the reference of the variable passed in the parameter rather than operating on the value. This results in the modification of variable in calling the function when they are modified in the function. In the example, we can see it is not only the value of n that is passed, rather a reference to n is passed. The parameter x is not as an int, it is in reference to an int. In this case, a reference to n. Therefore, when x is squared inside the method, what actually is squared is what x refers to n. Next. Here, before calling out the method, the variable x and n is pointing to the same memory location and refers as the S5. And after calling the method, the variable x and n is pointing to the same variable, but now the value of the both the memory location is 25. Next.
Now we talk about the output parameters. It is the third method parameter. So this is used to pass the output to the function. More about the output parameter. When we want to pass any number of values to the function and pass back any number of output, then we use the output parameter. So the keyword which is generally used is out. And the third point says that if you in the out parameter you cannot pass a property such as get and set property, you cannot pass inside the out parameter. Now for the in this example, in the out example, we see that the static method addition has 4 parameters. P and Q are the value parameters, whereas R and S are the out parameters. So the value that is stored in R and S is taken back inside through the out keyword, and it is passed to I and J variables, and that is how you get this output as 120 and 40. Then the fourth method parameter is the parameter arrays. These are the reference type, and that because it is a reference type, it can be passed as an argument to the method. So what do we mean by the argument? I mean, why argument? We can pass any element of an array through this method, and we can do this by using params keyword. So the second point says that if you want to combine a params argument with other optional parameter, you can do that. But there must be only one params argument in it. So the example here below says that in the first line we have three method parameters inside which there is only one params argument, which is okay. So this statement is valid, but the second statement, which has two params argument, is not valid. Now we will see the example where elements of an array is passed inside add element static method, and all this is passed because of the params argument. So we use params keyword here, and each element of an array is passed, and the sum of each element is stored inside this variable, and the sum of the array is displayed. Thank you.
So, hello everyone. So, my name is Parth, and today I will speak about the building about a basic class. Uh, so, what are the topics covered in this are introduction, create an object, adding methods and constructor, adding events. So, first you will see the introduction. A class is a user-defined blueprint or a prototype from which objects are created. Basically, a class combines the fields and methods into a single unit. In C#, classes supports polymorphism, inheritance, and also provides the concept of driven class and base class. So here there are the keywords and the accessibilities. So first we are having a public keyword. It can be accessed by any class. Then second we are having a private keyword. It can be accessed by only the member inside the current class. Then we are having the internal keyword. It can be accessed by the member in any of the class in current assembly. Then we are having the protected keyword. It can be accessed by the member in the current class or in the class that inherits from this class. Then we are having the protected internal. It can be accessed by the member of the current application and by the member in the class that inherits from this class. Then we will see the syntax of the classes. To create a class, one must define it by using a special block character. Public class, my class. This is an example. This is a syntax example. So one can also define many classes as they need in a same file. However, good coding practices suggest that in most cases you have to a single file for each classes. So after that, we will learn how to create an object. To create an object, you need to specify the class name followed with the object name and the new keyword. Then this is a small example of how to create an object, and it grabs a piece of memory to create an object there. So after creating an object, we are having adding methods and constructor. A method is defined with the same name of the method followed with the parenthesis. In C# provides a predefined method which is already familiar with us, such as main. We can create our own methods to perform certain action. So as we all know, next we are having constructor. As we all know that constructor is the same name as a class name and it invokes automatically whenever an object is created. So this is a small syntax example of methods and constructors. Then we will learn how to add event. Class can also use event to notify your code. To define an event in C#, you must first create a delegate that defines the signature of the event you are going to use. So this is an example of delegate using events that I have given here to explain how to add events. By this, I conclude my presentation. Thank you.
So hello everyone, my name is Ankit Gautam. I'm today explaining topic file type and reference type. So we'll see. We have used many variables, and if we divide those variables on the basis of memory management and memory allocation, we'll find there are uh, uh, two kinds of value type. There is a value type, and another one is the reference type. What is the value type? Value type is a basically data type which contain actual value that is given to the variable, and in the reference type it doesn't contain the actual value, it contains just the reference or the memory location of that value. uh, the value type stores the value at the stack memory, and reference type store that reference at heap memory. And some example of value type example is a boolean, int, character, float, and enums. And the some example of reference type variable are string, array, delegates, classes, and interfaces. So basically the differentiation between value type and reference type, that is that value type are static and reference type are dynamic. And because value type are static, it is a fast, and on the comparison of reference type with the value type, reference type are slow. Value type can't be resized, and variable and reference type variable can be resized also. And variables type store on the stack memory, as I said, and reference type store memory on the heap. And stack doesn't contain any garbage collector, so programmer has to do that garbage collector by itself, and heap memory contains a garbage collector, so programmer doesn't have to do unnecessary deleting stuff. And local variable get wiped as they lost their curly braces and the scope, but in the reference type it doesn't get lost even after it can lose the scope. So for the some example I am giving here is program. I'm creating in main method x variable and give y equal to x. And give here we know that integer is a value type, and x value actually contain the 7 variable inside it, and that 7 gets to copied into y, and after changing that you can see that x value is remains the same, but y value changes. So next is example of reference type. We all know that class is a reference type variable, and I'm creating class here as an employee, and after that in main method I'm creating 2 objects. First object 1, here I'm giving the employee name as Ankit, and the salary is 30,200, and next is employee sum name. And after changing that you can see that values of that variable gets changed even after I'm not declaring the employee 2 to change, but employee 1 also gets changes. So that one concluding. Thank you.
Hello, myself Arathi Nair. So today I am going to talk about understanding namespaces and assemblies. Why namespaces and what are the advantages of namespaces? So basically it is used to organize the programs, and it helps us to organize our classes so that they can be easily accessed by any other application. It is used to avoid conflicts between classes that have same names. For example, we can use 2 classes with same names but different namespaces. Thus, it helps in resolving same class name conflicts. Here it is an example where we write console.writeLine, where console belongs to system namespace. Namespace alias directive. It is a convenient way for referring to a long namespace name by a different or a shorter name. Sometimes we may encounter long namespace and wish to have it shorter. This could improve readability and still avoid name clashes with similarly named methods. The using keyword. It states that the program is using the names in the given namespace. For example, we are using the system namespace in our program. The class console ID is defined there. So we just write console.writeLine hello. These are the different namespace member. We can write another namespace, class, interface, struct, enum, or a delegate. Now what is an assembly? When create a project in Visual Studio.NET and compile it, assemblies are created. .ddl, .exe. And these assemblies are the fundamental units of applications in the .NET framework. And an assembly is a single deployable unit that contains all the information about the implementation of classes, structure, and interface. Components of assembly mainly consist of manifest, module, and type. So the manifest contains name and version of the assembly, interaction information with other assemblies. Module is either DDL or exe file. It contains compiled code or intermediate language code, metadata associated with module. And type is a class that contains data and logic affecting the data. So the functions of the assembly are, it supports execution, provides security, and supports side-by-side execution. Types of assemblies. Assemblies can be private or shared. The assembly which is used by a single application is called as private assembly, whereas the assembly which is used by multiple application is called as multiple shared assembly. And the shared assembly is also termed as public assembly. Thank you.
Welcome everybody. My name is Ritesh and today we'll be discussing about delegates. Let's see what is delegates. According to the formal definition, it's a type state function pointer. Now mind you, the delegates are a user-defined data type. A delegate holds the reference of a method and then calls the method for execution. There are two ways that you can call a method in a C#. Okay, the very first method is by using the instance of the class if it is a non-static method, and using the name of the class if it is a static method. The second way is by using the delegates. Now, how to implement the delegates? There are three steps that you need to follow. First step is define a delegate. Now, this is the signature of the delegate, how you should define it. All right. Now, we have taken two examples over here of two delegates. The very first delegate is the add delegate, and it has the method as add nums. Now, this add nums method is a non-static method. And second delegate is say delegate, which has a method as say hello. It is a static method. As the delegate is a user-defined type, in C, the types are defined under the namespaces. Namespaces is a logical container of types. Hence, we define delegates also inside the namespaces. Delegates can also be defined inside a class, but it is more preferred to define them in the namespaces. The second step happens to be instantiating the delegate. Now, this is how we instantiate the delegate. Now, mind you, add nums was a non-static method, so it has to be called with instance. So we have used the dot operator along with p as the object. And the second one is say hello, which is a static method, so you can call it in the static block normally. The third step happens to be now call the delegates by passing the required parameter values. So internally, the method which is bound with the delegate gets executed. That's the third step. Now, along with the single delegates, we have multicast delegates as well. So let us see that multicast delegates can be used to invoke the multiple methods. The delegate instance can do multicasting with using the operators. Using the plus operator or the minus operator can be used to remove a method from delegate instance. All the methods invoke in sequence as they are assigned. Multicast delegates are also called as combined delegates. They must follow the following conditions. The return type must be void. None of the parameters of the delegate type can be declared as output parameters. So this is an example of multicast delegates. You can look around it. This is the operations and this is the output. The third thing that we come up is with events. An event is a delegate type class member that is used by the object or class to provide notification to the object that an event has occurred. Events are declared by using the simple event declaration format as follows: modifier, event type, and event name. The modifier may be a new, static, override, abstract, and sealed. For example, public event, event handler, click. Event handler is a delegate and click is an event. This is an example of an event. Thank you very much.
Hello everyone, I'm Eabez Thankachan, and today the topic that I'm going to explain is exception handling in C#. So the main topics that we are going to cover in this session is introduction, keywords, syntaxes, and the exception classes in C#, and throwing objects. So what is exception handling in C#? The C#'s exception handling features helps you deal with any unexpected or exceptional situations that occur when a program is running or is in execution mode. In general, an exception breaks the normal flow of execution and executes a pre-registered exception handler. Now, it has specific keywords for it. Exception handling uses the try, catch, and finally keywords mainly to try actions that may not succeed, to handle failures when you decide it's reasonable to do so, and to clean up resources afterward. Now, there are four main keywords that are try, which is a block that identifies a block of code for which particular exceptions is activated. Then we come to catch block, which is a program which catches an exception with an exception handler at the place in a program where you cannot handle the program. Then we come to the finally keyword. The finally block is used to execute a given set of statements, which whether an exception is thrown or not thrown. Then we come to the throw keyword, which is a program which throws an exception when a problem shows up. Now, next is the syntax of exception handling. Now, a try catch block is placed around the code where the user is accepting or expecting an exception. Now, the syntax is as follows. This block, which consists of try and catch block, is placed around the code where the exceptions or the errors are expected by the user, and when the error is caught, this exception, which is defined by the user, is given. Then we come to the exception classes. There are various exception classes. Since C# exceptions are represented by classes, there's some examples of exception classes are system.io.exception, which is an exception class that handles the input-output errors. Then we have some exceptions of classes such as system.array type mismatch exception, which handles errors generated when a type is mismatched with array type. Then we have system invalid cast exception, which handles errors generated during typecasting. These are some examples. And then finally, we come to throwing objects. You can throw an object if it's directly or indirectly derived from the system exception.class. The syntax for throwing objects is given below in this example. So this was a basic information about what exception handling in C# is. Thank you.